Everybody, and welcome to our presentation on volume. I gotta tell you, technology has been just giving me a run for my money today. Actually, all this week, I've learned a ton of new stuff. This is one of them, an Edpuzzle and all this jazz. So I thought I had picture in picture. You could probably see me all frazzled with my hair all up in arms, but really, no, that's not true. But anyway, I can't figure that part out, so we're going to go with just the volume. We're just going to go with my voice today, and it's this Friday afternoon. I'm getting ready for Monday, so I am heading for the weekend. So I'm pretty excited about that. And so you're going to get my voice, and I'm done messing around with the technology. Okay, so today do now in the classroom. And what we're going to be working on today is we're going to be working on the volume of a cylinder. And then given the volume of a cylinder, we're going to find the radius and the height. Okay, so we're going to be working both ways, and then our homework is going to be Edpuzzle. All right, so this is Mashup Math, and we're going to listen to what they have to say about volume. Now he says surface area here. We don't care about the surface area right now. We will care about that later, but not right now.
Hey again, Anthony here. Welcome back to Mashup Math. Thanks again for joining me on this lesson. Let's just get right to it. What's up again, everyone? Thank you so much for stopping by and for joining us as we explore in this lesson on how to find the volume and surface area of a cylinder. Here's a question. What does a cylinder even look like? Well, we actually see them every day in things like paint cans, potato chip cans, and containers of lip balm. Balm is kind of a weird word, isn't it? Anyway, back to geometry. So in geometry, we have a very standard diagram for what a cylinder looks like. And we can think of this diagram as one of those objects that we just looked at, except that it was made out of glass and totally see-through. And we should also note that all of the concepts and relationships that we are going to discuss concerning cylinders apply to any and all cylinders of any size, shape, or orientation. Okay, so now our next question is, what's the deal with these things? How can we relate things that we've already learned in geometry, things that we already understand, to this new concept of cylinders? We can think of creating a cylinder by starting with a circle and creating a tube-like shape where the size of that original circle does not change no matter where you are inside the cylinder. So this is a helpful concept to understand. So let's go ahead and visualize it one more time. So now let's direct our thinking towards finding the volume and surface area of a cylinder. Now we can find both of these things using a formula, provided that we have two pieces of information. That is the height of the cylinder and the length of its radius, which is the radius of the circle either at the top or the circle at the base, or really any of those circles in between that are inside the cylinder. Now we know that volume represents the amount of space inside of a closed figure. So we can think of the volume of a cylinder as how much it can hold inside, maybe if we were to fill up a bucket with green paint. And we know that surface area represents the amount of space it would take to cover up the outside of a figure, like if you were going to wrap it with wrapping paper or maybe spray paint it with some kind of a design.
We're going to probably deal with surface area next week.
Cool. So now we're ready to go ahead and familiarize ourselves with the formulas for finding both volume and surface area of a cylinder. The volume of a cylinder can be found by multiplying pi times the radius squared times the height.
Okay, so that's the one we're interested in right now. This one right here is what we're interested in for our sections. We're not going to be doing the no surface area, but we are going to be doing the volume.
This area can be...
Okay, so let's take a look at practice problems. Here's a couple practice problems that we can put in play that he's going to show us about a volume.
represents the amount of space inside of a closed of 2, and pi and the radius by the sum of the height and the radius. So to visualize this, we're thinking about how many coffee beans can fit inside of a cylinder-shaped can. And since we measure volume in cubic units, we're actually thinking of this, our answer, in terms of how many 1-inch cubes of coffee could fit inside of it. Can be found by multiplying pi.
All right, let's see if I can find this. Sorry, guys. Here you go.
To look at this example, which is what is the maximum volume of coffee beans that could fit inside of a cylindrical tin with a height of 8 inches and a radius of 4 inches. So next, let's highlight the key information. In this case is that we want to find the volume of the inside of a cylinder with a height of 8 and a radius of 4. So to visualize this, we're thinking about how many coffee beans can fit inside of a cylinder-shaped can. And since we measure volume in cubic units, we're actually thinking of this, our answer, in terms of how many 1-inch cubes of coffee could fit inside of this can. So at this point, we can revert back to that simple diagram of a cylinder. And we know that the height is 8, so we can label the height with the value of 8. And the radius is 4 inches, so we can label the radius with a 4. And now we can use our volume formula, V equals pi r squared h. We can replace r squared with 4 squared since the radius is 4. And we know that 4 squared is just 16. Then we can replace h, the value of the height, with 8 since the height was 8 inches. And now all we have to do is multiply to get our final answer. Pi times 16 times 8 is approximately 402 cubic inches. And remember, that means that this can could hold approximately 402 of these little 1-inch cubes of coffee.
Okay. So now we're looking at this. So this is our formula that we're going to be targeting in here. We're going to be targeting is that the volume equals pi r squared. So hopefully this looks familiar to you, because this is our area of our base times our height. So we could say our area of our base, which is our capital B, times the height. So this pi r squared is our area of our base because our base is a circle. So we're going to plug these things in. So the volume equals pi, and then our radius is right here. It's halfway across our circle, which is 3 squared. We're going to times how tall this is, times 6. So the volume equals pi times 9 times 6. So we put this all together in our calculators and we plug it out. So we have 9 times 6 times our pi, and that gives us 169.6. So the volume equals 169 this is to the nearest tenth, 6 meters cubed. So am I going to be looking for units for meters cubed? Absolutely, because area is squared, and if you leave it without any exponent, it means that you are in linear length and you are not fully understanding volume. So make sure that you put this in meters cubed. Okay, so here you can see, again, we have our capital B in here. That gives us our height. This is our area, and this is our capital B. All right, looking at our practice problem that we have right here, we have the volume of this cylinder. So we want to know the volume. So we know our formula is V equals pi r squared times 8. And I will be giving that volume formula to you. And whenever you need it, you can have it on your forms or whatever you need to be able to have to figure out the volume. So the volume equals pi, and then the base right here, it's laying down. So this is still our base, and our radius is 4 squared, and our height is 15. So V equals pi times 16 times 15. So 16 times 15 times our pi equals 753.98. 753.98. This doesn't say whether we should have it in to the 10th or to the 100th, so I'm going to leave it in this form in here, and then it's feet cubed. So we have our area of the base times the height. Okay, in our practice problem here for finding the height. So now we need to find the height in order to figure out, and it's given, our volume is given to us here. So we plug our stuff in here, pi r squared times the height. So in our volume, we know what it is. It's 314. That's our volume that we have in here. Right now, this is our diameter. So the height, the radius right here is 5. So this is our diameter, and this is our radius. So pi times 5 squared times the height. So we're going to solve this as an equation in here. So we have 314 times 25 pi times the height. Now you could multiply this out. It doesn't tell you to leave it in terms of pi, but I'm going to leave it this way because it's easier to keep track of with our decimals. 25 pi, divide both sides by 25 pi. So the height equals 314 divided by 25 times pi. So plugging this into our calculator, it would look like this. 314 divided by 25 times pi is 78.54. So we have 314 divided by 78.54 gives us, I pushed in that, 314 divided by 78.54 gives us 3.99, or the height is 4. .9976 or 4, and our units are inches. Now this is a linear foot. This is a linear unit in here, so there's no squaring in here because the cubic side, the 314, has our units in it already. So this is just the height, and it's 4. It's a height of 4. Okay, so take a look at this one right here. We're doing the same exact thing. We have our radius. We need to figure out our radius here. So this is 4 and 4. So we put in here, we need to have our height. So our volume equals pi times our radius squared times our height. So the volume equals 176 equals pi times 16 times our variable, the height. So I'm going to divide both sides by 16 pi. So we're going to have 176 divided by 16 over pi, and that, dividing that whole thing out, 16 times our pi is 30.3, which equals 176 divided by, that answer gives us 3.5. So our height is 3.5 centimeters tall. So this value right here is 3.5 centimeters tall. Okay, so we're looking at a challenge problem in here, and we're looking at our figure, which we could say is a composite figure of a volume, but really we're looking at this figure right here, this cylinder that we have in here. So we're looking at, we don't need to know the neck of our bottle because the neck of our bottle isn't going to excuse me, have any water inside it. So we're just looking at the bottle part that we hear. So we're going to figure out the volume of this, and then we have our conversion factor right here of 1 cubic foot equals a gallon. So if we put this in place, we can see that we can find the volume equals, our radius here is 0.5. So it's pi times 5.5 squared times 1.7. That's the height that we have in here, 1.7. So it's 1.7 feet tall. So it's not super tall, maybe up to a little past my knee. So the volume equals, and we can plug all this in to be able to see what we get. So we have 0.5 times 0.5 times 1.7 times the pi, and that gives us 1.34 feet, or cubic feet. So 1 cubic foot equals 7.5 gallons. So 1.34 feet cubed. We can set that up as a proportion, or we can multiply across. So 1 cubic foot is to 7.5 gallons. So we're going to multiply that across, and that gives us 1.34 times 7.5, which gives us 10 gallons. 10 gallons. The other way you can say this in here. So we're going from 1.5 to 7.5 gallons. So for every one cubic foot, it's 7.5 gallons. So 1 gallon is 7.5, or excuse me, 1 cubic foot is 7.5 gallons. So it's going to be more than 7.5, but at that 0.3 of a foot is 0.34 is times 7.5 will give us that partial gallon. So you can think about it that way. 7.5 times 0.34 gives you that amount is 2.55, gives you the value plus 10, or excuse me, plus 7.5 will give us our 10 gallons. So if you're working on one of these problems and you can see something like that, these are challenge problems that we have in here, but we're converting from feet to gallons. If you are a little lost in here, just keep in mind that this is what we're looking at right here. We have 1.34 cubic feet, and then a cubic feet is a gallon, and that's a little bit of a reach for us putting a challenge problem in place. Okay, all right. Have a super day.